Welcome. First, I'm gonna tell the plans for our framework, where it's heading exactly, and what you should expect in some near future. First I'll tell you about the last 1.15 update and why you should be intrigued, and you should also install it as fast as you can. Well, the most important thing I think is that, let's just recap on how you do things in Apparatus. You can basically iterate or operate the queries in two main ways. So it's getting warm here. So there's basically two ways you can iterate things in Apparatus: the solid one and the liquid one. The liquid one is coming by default, and it's pretty much do everything you want whenever you want. So you can structurally modify your entities, your subjects, so they contain new details, new traits, or they can, or you can remove the traits from them. And this basically means that you can't really iterate on them in a concurrent, parallel way. So if you want have separate asynchronous how do you say it? Parallels, to make to solve your mechanic in a parallel fashion, you have to make them solid first. So it's freezing their structure, making them less flexible, but they can now be iterated in a parallel way. And this inflexibility is can be quite limited sometimes. So say you want, this is some of my codes here. So you might want to separate. Sometimes you want adding a traits in what. Well, let's make it. This was made so long ago. Not really fine now. Getting the mechanism for the current world. This is not needed at all. You should really be writing one-liners as of now, because Apparatus is quite versatile now. Just make everything in one line. This code is for a smaller game, and parts of it will actually be available for the download, and I'm gonna tell about this a bit later. So you basically enchain. So you basically enchain the mechanism using the filter and operate, let's say, enchain solid. and operate concurrently. So this is how you do the parallel operation, basically any multi-threading inside Apparatus. You first enchain into a solid chain, a chain that's making sure that everything is consistent, everything is like frozen and divided into separate groups, separate workloads for the actual iterators, actual mechanics, I don't know, actual asynchronous tasks. And then you're making actual operation, actual iterating and operating, with this operate concurrently method. And this method is like, it's actually creating some separate instances of this lambda. It's actually a functor inside C++. So every lambda is like a wrapper over this stateful object with its calling operator, with its like inside this lambda is like, say, this type. With this operator overloaded. So in C++ you can even overload so this is basically it. No, well, it's basically the same thing, and this struct also contains the passed in how it's called, captures, right? So every capture you're mentioning here, right? You can mention, for example, I don't know, let's say now you can basically modify this inside this thing. I'm jumping from theme to theme, but should mention that if you're doing some kind of stuff like this, you should really be using the atomic values because they're thread safe. Anyways, so if you're like capturing this local variable here, it's actually passed into the state of this functor. So you're basically having a pointer to this, or a reference to this value here, and you can, of course, you can use it inside of your overloaded operator. So anyways, for each thread this functor is created for you with this exact lambda implementation. And this exact lambda implementation, it actually, as I said before, it can't really use much methods on the subject. So if you say, well, you won't be able to, but if you try to do something like set trade here, I can do it in one line actually, something like that. Perhaps it has two like coordinates. So if you try to do something like this for the, of course, solid subject, because you're inside solid chain, you basically can't have anything beside these solid subjects. If you try to do something like that, you won't even be able to compile this code. There are also runtime checks. So if you like casting from solid subject to normal one, you can actually do this in an explicit fashion. You still won't be able to set trace for it, because the state is preserved by this in-chain solid method. So what should you do? Before this 15th update, you were pretty much stuck. You really can't do any, so say, structural changes on your subjects, on your solid subjects. But now you can, and there are a family of methods. They are called Deferred ones. We don't have the manual for them now, but they should be in the online manual, online API reference. Here you go. Yeah. I can see behind the camera, but you I think you're pretty much, yeah, you're seeing what I see. So deferred trait setting allows you to set the traits even for the solid subjects, and you can remove traits, you can set traits, you can remove all traits, you can even spawn subjects. So if you're working on a mechanism, yeah, if you're working on a mechanism itself as a whole, you can spawn subject in a different way also. And what does this whole terminology means? What does this deferring refers to? This basically means that the operation itself is not performed immediately. So you're like setting for the future or changing for the future. If you're familiar with some kind of, I don't know, SQL designs, SQL drivers, or some relational databases in general, it's like a transaction basically. So you stack up multiple operations for the future, and when the time is suitable, when the time is like the context of this time is like safe for this operation to perform, it's actually performed. And if we're yeah, like a queue, right? Yeah, like a queue, much like a queue, and a queue of operations to come, a buffer, so to say. And for example, if we are going with our present example, this would be like so. If I'm to query this exactly trait after calling this method, so I say, like in some if, for example, I'll be doing like so let's say I want this here for some reason. This won't work. This won't actually work as expected, because this operation hasn't really performed its logic. It will be performed in the main thread later, when this concrete mechanic is finished. Yeah, it's basically operate concurrently that applies these so-called deferred operations automatically when it's done. So every operate concurrently by default just makes sure that every deferred within itself is applied when it's done. So when like for example maybe 4 or 5 or even 16 like threads all came to an end, all of the deferreds are automatically like how do you say it, like collapsed, like applied. Yeah, it's a bit of a wording. You can actually express this behavior with a special new argument. It's basically an enum that's telling what kind of deferreds it should apply. You can actually apply only, like, for example, subject spawn deferreds. So multiple deferreds, multiple types of deferreds here, but only the subject spawning gets applied. So say I can now do a thing like this here, because we're only capturing value, for example. We're not capturing this thing. We can, of course, but if you don't want, or maybe for some other reason, you can actually now provide this argument here. So yeah, and for example, so this thing actually fails because the operation is not like normal set rate. It's a deferred one, and it gets delayed, so you won't be able to get it right after you set it here, just when this whole mechanic finishes. Yeah, so mechanism, spawn subject, deferred. Yeah, so if you have a bunch of these, you can apply them explicitly with the subject spawn argument. And the, for example, and these won't be applied at all. So only one type gets applied, the one that's specified here in its fourth argument after the thread specification. And you can actually, and by default, specify all. All of them are turned on by default, so all of them are applied by default. You can also pass in none, and that pretty much disables the automatic collapsing of these deferred operations. So maybe you're having like multiple concurrent operatings in your logic, right? So you have multiple of those, and you just want to apply them at once, sometime, all the deferred operations at once, sometime later. How would you do this? Well, there is a special method called mechanism apply deferreds. So this thing gets this method gets all the things done. It guarantees that all of the deferred operations, whenever and wherever they were like buffered, all of them get applied here. And yeah, so this system, the implementation of this whole paradigm of deferred commons, deferred operations is quite versatile. You can like combine all sorts of different approaches here and control them pretty much in all manual way to gain maximum performance. And when actually you should do this deferred logic, for example, because it's if you're like, I don't know, estimating the cost, it's not free. Like you have to maintain a separate queue of things. You have to maintain like some additional copying, because when you're setting the trade's deferred, the trade gets serialized to a special object, a newer and updated one called trade record. When you spawn this object, it gets its prototype, because you can actually, and it's pretty useful, you should use it. You should like, you can like pass in the type of traits you want this with. So you can do some pretty cool advanced things here. Yeah, it's pretty flexible, pretty useful. You can just spawn the deferred like so, pass in the trait objects right away. And these are also copied. So these are copied into a separate container-like object called, and it's actually a newer one. It's called the subject record, the one that maintains the serializations, the state. It's like a refrigerator for the trade that's actually not part of any chunking. So it's like if you've used Struct on Scope, the Unreal's one. It's like so. It's like that, and it's a way to grab, to dump a subject, and it will be useful later when we are actually implementing the whole system of dumping the global state of the mechanism. But now it's just like an intermediate form of subject, the one that's not yet part of apparatus, not part of any mechanism, but it's like a safe state for it. And actually, it can be used for the safe states later. We'll be coming to this. And yeah, so a bunch of things are happening. The copying, the queue management, the buffering, the logic behind the appliance, the application of these commands. Lots of stuff is happening internally, and surely it's not free. It's actually log free, so it's not using mutexes inside. So it's multiple producers, single consumer pattern is this pattern is utilized internally, but it's still not free. So you may ask, when should you actually use this deferred concept? You should use it when you're like, when your main logic in your lambda, your mechanic logic, is a lot harder, a lot more difficult, a lot more performance consuming than these trade-offs. So you really should balance, you really should test, benchmark, and see that if you're like calculating a bunch of stuff, maybe even some internal cycles are here, maybe some like prediction logic, maybe even some neural analysis is here inside this lambda, right? If it's so, then maybe the trade-off of maintaining these buffered queues, these buffered comments, can be like neglected. Yeah. So is this a correct word? I think it is. So it's how do you say negligible? How is this pronounced? Forget it. So if the whole logic is too slow, and you can't really do anything but make it in parallel in multiple processes, you should be using the deferreds. Yeah. If you're like, I don't know, if you're like incrementing a number, for example, for some trait here, so the operation is pretty trivial. For example, you're like, say I'm getting this by reference because I'm inside solid some value, and it's just +1. Yeah. And or maybe how would you do this exactly? I wonder. So it's like something like that. Say you don't have anything but this thing here. Yeah. So if you're just doing like some variable state, some state variable increment here, and set it in a different way, it's pretty much an overkill. You should know. Yeah, the process of copying, the process of managing these common buffer will most definitely be too much of a problem to undertake for such a trivial operation. You should like refactor this code in something else. So this is the Deferred kind of the new Deferred kind of operations. A new way to make concurrent operating a general purpose one. Yeah, so maybe some questions for this exact topic. For the different ones, I remember that I was asked some questions in the Discord, and surely I will sure answer them, but I want to like chat with the live people first. So questions for these new deferreds, for the new deferred functionality. Was it clear on how to use them? Maybe some additional patterns I should discover. So maybe for the next stream, right? All right. Yeah, so let's go to the next topic, I think. Yeah, so in its current state, basically Apparatus is becoming like an SQL driver, really. Sorry? No, sorry. About the question is about blueprints. Is that functionality also available in blueprints? Unfortunately, it's not even officially thread safe. The blueprint functionality. It's not like the whole virtual machine. I'm not 100% sure it's thread safe. So I was like, there were some actual designs for implementing the concurrent operating inside blueprints, but I think it's not like viable at this moment because it's these concurrent environment, this multi-threading environment. I don't even sure if the virtual machine is thread safe, and implementing such a big functionality inside blueprints will be like very risky and hard to support. There are solutions on the marketplace that allow for the concurrent execution, not official ones, and maybe we'll be coming to this. We'll be implementing, maybe sometime in the future we're going to implement the multi-threaded mechanics, but for now, and well, the blueprint workflow is mainly for some, like, I don't know how to say this. You shouldn't really be targeting performance if you're going with blueprints. I mean, come on, it's not gonna happen. It's not gonna happen with Apparatus or any other solution, because it's pretty much a heavy lifting job to go with the virtual machine, with this virtual stack, because it's basically a virtual machine. It maintains its own stack, its own order and state of execution. It's like a processor about the physical one. So you won't be getting much performance with any solution, basically. You can actually wrap up some C++ functionality, right? Make it into a C++ and into a blueprint function, and make and gain some performance for itself. But it's not blueprint code in the end. It's just a wrapper, again. So if you're going for performance, you should be learning how you should be investigating how to do things C++ way, and it's not that hard, because when you're going with Apparatus, and Ethan can actually quote me on that, because he didn't, this guy from our Discords that actually didn't have any experience, any C++ experience, and was kind of like I don't know, it was like a discovery for him, because he was not hesitating to go C++, and he didn't regret that, because you don't really write much C++ with Apparatus. Everything you do is just like, well, you copy and paste. You copy and paste these like templates, right? And add these things. So you're not doing any of the classic C++ stuff. You don't do much hierarchies. You don't do much virtual method management, anything like that. You don't do that. You're basically writing some static functions, some static code, some lambdas, and that's pretty much it. So it's not C++ hard. It's like a subset of C++. You know, when Unity actually did this whole dot stack, they went on implementing a subset of C#, just because the whole ECS design, the whole ECS pattern or paradigm, it didn't really require much more than just structs, I don't know, functions, even static functions. And that's basically it. You don't need hierarchies, you don't need classes, anything like that. So they went on implementing the compiler for the subset of the language. And when you're doing C++ with Apparatus for Unreal Engine, the situation is quite similar. You don't do normal hard C++. You can call it even hardcore C++. You're like using a subset of features, a rather small one. So you're just calling some basic stuff, using some operators, maybe some function calls and things like that, but it's pretty basic, right? You don't have to be advanced C++ programmer if you're doing stuff the ECS way, the Apparatus way. So if you're going and if you're targeting real world performance, you should be going C++ anyway. You'll always get penalties if you're doing blueprints. Again, this is not related to Apparatus itself. It's like getting the most of blueprints. Really, the iterating process, even inside blueprints, is quite fast, exactly. But there are certain things we can't technically overcome, and that's why you should go C++. Yeah. The next question is like, Deferred doesn't initialize initially, right? Would it be useful for fixed physics? Deferred doesn't initialize initially. What does this mean? I wonder. Well, if you're talking about deterministic physics or like determinism in general, well, if you're doing concurrent deferreds, so coming up from multiple threads, and this is not going to be deterministic, unfortunately, because you may have a certain trait, certain components, so to say, first on one machine being added or queued, and on the other one the order will be different. So, well, multi-threading in general is not considered deterministic. It can be made deterministic with some special precautions, but deterministic physics or fixed physics, fixed point physics, it really should be doing stuff single-threadedly, because it's quite complex, and you'll be like it will be really hard to make it deterministic, to make it multi-threaded deterministic. Yeah, it's kind of a big deal. I'm not sure it's even viable. Yeah, you can actually implement some core stuff in the single thread, and make some additional visual stuff, like maybe some not core logic dependent stuff using the paralleled multi-threaded workflow. Time to learn C++? Betcha, because you know you're most safe if you're going C++. Even if you're like maybe a C# coder now, or maybe a Java coder, or basically any other language coder. No, well, maybe the Rust is quite snappy, but doesn't matter. Any like virtual machine coder should learn C++ if he's like targeting some greater performance, some real world scenarios, consoles, things like that. Because you're, of course, well, business logically wise, you can implement like anything you do in C++, you can implement in C# or Java or even Python maybe, because there are wrappers over OpenGL, over Vulkan, I'm pretty sure, over DirectX, so you can do it, right? But you'll always be lagging behind. If, for example, you're like, I don't know, maybe coding for a smartphone, right? Making some embedded programming or things like that. And maybe you're like power limited. So your device is like draining power. Yeah, so if you're going with C++, it's not only about the performance of some FPS. If you're getting like some additional free cycles on the CPU, you're actually saving the power, the battery, and you should also think about that. So yeah, if you're going real-time graphics, if you're going real-time physics, you're pretty much stuck with C++. Yeah, there are Rust and other compiled languages using LLVM and things like that, but the infrastructure is not quite ready for them, I think. Not so many libraries, not so many environments, and I suppose you just learn C++ and feel safe, career-wise also. Yeah. Books are fine. Reading books is great. Yeah. So learn C++. Don't be afraid of it, because you won't be learning the whole thing. You're basically like, I can tell you what you need. Apparatus logic can also be made, can actually be made almost all in header files. So you're not even writing these C++ things most of the time. They're pretty basic, just making some global state here. So and even this is not like mandatory only for this exact class. So you're basically writing some copy and paste. Yeah, it seems like a lot of code here, right? Bunch of stuff. But you will be just copy and pasting these things. They are most identical. Yeah, you will need to learn about some types, but the Unreal's manual is pretty like well, it should be enough. The online manual, you just search for things there. So for example, you need some bounding box functionality, so you search it and you get it, right? And then you just copy and paste these properties like you need. much like you just adding them. You can learn by just doing some simple stuff, right? Some simpler logic, and then expand on that one, and you will soon understand that actually maintaining this C++ code is a lot easier than maintaining these visual nodes and stuff. It's blueprints are fine for prototyping, for some minor logics, for UI stuff. It's pretty useful because you won't recompile everything when you change blueprints. You just save and then you're ready to launch the game. So you iterate faster in blueprints. But for your main game logic, for some core functionality, yeah, you should be going C++, and you'll get used to it, and you'll understand that it's actually a lot better. The written code is a lot better to manage than blueprints. If you are ever to merge, if you're working with the team, and if you're ever to merge the blueprints, the blueprint code, well, it's pretty nasty. Say you have a conflict, two people have changed the same blueprint, and you gotta merge it. There are tools inside Unreal, but it's pretty nasty. It's pretty hard. Yeah. So yeah, gotta go C++, and shouldn't be afraid. If it's possible, I would like a basic example of filtering. If you see it fits. Well, so yeah, let's go with examples a little bit later. I'm just going to say and to sum up. So this new update, it makes everything like targeted for general purpose concrete programming. So basically any kind of logic can now be parallelized and made multi-threaded. And another thing is the new record functionality. So you're now having two kinds of records, serializable objects called subject record and trait record. The subject record is basically a bunch of trait records. It's a new container to serialize, to make subjects persistent. And the plan is so now we have this deferred functionality based on these records, and then we are going to have a runtime dumping of the mechanism to make to be able to view the state, the global state of Apparatus right inside Unreal Engine. That's what some of our guys actually wished for from the start. So if, for example, you're using like maybe if I'm not sure about Flex, maybe NTT is using a separate server to inspect the entities. I'm not sure, inside browser. And you will be able to visualize what you're having, how many subjects, what are their structure, what are the exact components, traits are there in the subjects. And you still can do this for the details, because they're part of the Unreal's world. You can highlight certain objects right inside the play mode, and you'll get the exact state, so you see the details in them, but you won't see the state of the subjects, the low-level subjects with their traits. And this new functionality, planned functionality for the dumping of the mechanisms is exactly for that purpose. So you'll be able to highlight a certain mechanism inside Unreal's world, click on the dump button, create a file that's pretty much like a frame dump of all the state of Apparatus. So every subject will be serialized into a subject record, and you'll see its state right inside the details panel or inside another window, for example. So it should be pretty useful. That's what is actually planned. Another important thing, we've actually launched the toolkit now. Yeah, it's gonna be here. I'm gonna post the link. This new repository, it's called Apparatus. So it's finally our official toolkit. We're gonna implement bunch of stuff here. There is already a bunch of stuff here actually. It's gonna be separate like plugin, an open source one, a BSD one, so it's like very very free, so to say. You can mix it, you can branch it, do anything like that. And what's gonna be a part of it? Bunch of stuff. We're actually now pushing some of our internal library code we're using inside of projects, multiple projects even, concerning physics and the rendering. So now you have like bunch of stuff, bunch of files here. You have trade renderer component. This is like a transitional component from the instant static mesh to the Apparatus world, and it's a pretty cool pattern that you can use, remix. And yeah, so you basically just supply it with trade type, for example like f-enemy or something like that, and set it with the mesh you want this kind of object to be rendered with, and it handles everything itself. So it's like Apparatus entity renderer using the instant static mesh. Another thing is called bubble cage. It's a pretty basic spatial and quite an efficient one, collision detector and collision resolver. So you should be using it when you need things to be like physically based. Well, for example, this bubble topple demo, it was made using the similar approach. Yeah, this one. It was made using the similar approach, but this was made in blueprints actually, so it's not really that efficient. This one is C++ implemented. It should be a lot faster. Yeah. So use it, remix it. If you need some additional functionality, pull requests are welcome. But we're going to populate it with our stuff also. Yeah, this is called Apparatus. You can actually make it into a subtree, a Git one, or a module inside your project. So you pull the changes from there. Yeah, you can study the code here. You can actually, if you're going to write and learn some C++, you can use it pretty much as a reference. So you can learn some stuff here on how things are done in C++ and Apparatus. Let's go next. About these C++ performance issues, yeah, this static analyzer for the C++ code can actually be quite heavy, but as of now I'm pretty much writing the code without any IntelliSense support inside this Visual Studio Code, and I'm fine with it. I know I'm missing a bunch of stuff like prediction and completion, but anyways, this works for me. So I'm currently working with some raw code. The only thing I'm getting is like this syntax highlighting, and it's pretty much it, and it's fine. You can get used to it. Of course, if you're launching the Visual Studio, the main thing, it can be really slow. I got one, but I'm not working in it. I'm basically going Visual Studio Code and writing just the code here. You'll get used to writing the correct one from the first try, and it gets some time, but you will be fine. Don't be, as a programmer, advice general one, don't be too dependent on the tools. Be ready like to write code in Notepad. It's kind of a good skill to be versatile in this matter. I know some people are really stuck with some idea of their choice. I don't think that's a healthy approach for the engineer in general. So I'm like having multiple stuff here. I mean, I even have C-line. I'm not working at the moment, but I still got it. Trying to be versatile here. Yeah. Яков, ты, в общем, да, не переживай, мы потом подзагрузим этот стрим на официальный канал Toolbox, и там, в общем, все будет. Ну, по идее, здесь ничего нет того, что ты не знал. Вот, поэтому пока еще не было. Ну, про деферды поговорили, но мы и с тобой про них тоже поговорили, так что, в общем, все будет хорошо. Если что, да, зааплодим. Yeah, it was quite fun with this, quite funny with that missing channel. I'm not sure even why this happened. I've heard I didn't hear myself in the headphones, right? The right channel, but I thought it's some kind of a headphone problem, but it turns out it may be actually related to the microphone, and it's really strange. It's really strange. It used to work just fine. Anyways, so the microphone should be stereo, but anyways. Yeah, so this high count game project, we're actually in partnership with some other guys, and we're still coming with our own game like demo stuff. So it should be coming, right? We're not really a graphics based company, though I'm initially actually a graphics animator 3D graphics animator, but we're not like into making content, and that's pretty much the main problem for us not to release anything, uh, anything like game level ready product to represent Apparatus in the best way possible, because we're not into doing some half-baked stuff also. And yeah, so we're currently currently in partnership with some other guys, and I hope we'll be able to show some real fun stuff, basically made in Apparatus, right? It's not like a real AAA grade kind of project to wow everybody, but it should be playable, right? Apparatus is like an add-on. It's not a project of its own. It's not it's not an Apparatus Lite version. No, it's like an add-on for Apparatus. It's like a utility kit. So you get the Apparatus. It's made for the core ECS functionality. And if you want some additional stuff like collision detection and things like that, and you were like in the mood of hacking stuff to optimize it for your own needs, you're basically using like a palette. It's using Apparatus like palette, grab some things from it, maybe revoke them for your needs, and optimize them for your needs. Some of our internal receipts, basically, some of our internal methods of doing stuff. Yeah, and if you want, you can actually start your own utility kits. Maybe make some other additional stuff. It's all welcome, of course. Yeah, well, it's another question about why we don't make any more samples than our default platformer that's quite lacking, in quite narrow functionality. Not a bunch of stuff is there, but our main audience now is like the people who actually know why they're coming for ECS. Yeah, who are very tech savvy, who are very engineering savvy. So they are know. So they basically know what they are doing, and not a really bunch of stuff is like different in Apparatus than other ECS implementations. Yeah, of course we are making it like truly native to Unreal Engine's world, and it's very important. But in terms of paradigm, that's basically ECS. Yeah, and so those people don't really need much of samples, but of course I understand that for the new buys, or maybe for some not ECS not ECS savvy people, a bunch of new additional samples would be useful, of course. And well, for now, the functionality for Apparatus is pretty much complete, I must say. So, of course, there is always room for improvement, for some additional features, for some additional utilities, even the core level ones. But it's pretty much complete, and I'm sure we'll be going for some new samples. And that's quite, I must say, quite business logical, because new people coming for Apparatus, they want more like out of the box bootstrap projects to start with. Go with Apparatus to start making things the easiest way. The paper planes project is not like it's, well, when we released the platformer sample, it was quite quite ready, I think, in terms of quality, and the paper planes is pretty much a demo. It's not really tidy, I must say, to be released, but we'll think about that also. Yeah, and some of the questions asked in this channel. A way to combine details and traits into a group for a feature. No, that's not really possible at this moment. I'm thinking about how to implement this thing, and maybe you just go with your own like manager for this kind of functionality, to be like to have like certain components automatically work with together with like in combinations, automatically come in combinations. Maybe you just implement some of your own routines for this purpose. I'm not sure if this functionality should be a part of the core one, but I'll think about that. Do mechanicals need to be on the game mode? This seems to be wrong place. If you have multiplayer game, this game only exists on this server. This depends. You can actually create a bunch of actors. The game mode itself is pretty much just an actor coming on the server only. So you can have multiple actors, multiple mechanical actors doing multiple different stuff. So you can have like client only mechanicals, server only mechanicals, and things like that. Is there a concept of optional detail? No, and yeah, I'm still not sure this is coming to the core functionality. Yeah, so it's like an optional, so it can be present and can be absent. More like a syntax, seems more like a syntax sugar for me for now. What is the efficient way of getting or setting logic connectors? Set location, for example, feels it would be not be from cache. Yeah, of course. If you're going with actors, you pretty much lose the cache efficiency. But this whole cache efficiency thing is actually overrated, I must say. It's not really a lifesaver in some real world scenarios. So you should test things first. Yeah, we're using mostly instant static mesh components. Not sure about this 6th question, actually. Might answer this later in the Discords then. Well, yes and no about the 7th question. Let me get this. Yeah, sometimes you have actually some performance benefit, including when you're using traits, but it all varies. It varies on the logic that you're actually implementing. Well, there are a bunch of ECS implementations actually, but they are all mostly C++ based and not really integrated into the Unreal's world. And that pretty much makes them not our computer, not even competing ones to our solution, because they're pretty much C++ libraries. They may be good ones, but they are not really targeted for Unreal Engine. Do you have some best practice of some pitfall to avoid? Well, you basically like you have to test things before going either way. You should be designing your ECS systems mechanics to be as pipeline like as possible, to be able to drive really large amounts of entities. So yeah, you're like designing a factory for processing the entities. So you should be designing well efficient pipelines, and you should always benchmark your logic. Yeah, and Apparatus is actually quite fast on its own. It's quite fast on iterating things, on selecting things, selecting subsets of things, and you shouldn't really worry too much about this stuff. But in terms of your own implementation, yeah, there is quite a broad range of possibilities, and not all of them are the best solutions in terms of performance. But if you're going ECS, you should really be considered about the overall feel for development. I think it's far superior than object-oriented programming, even if we are not considering the performance benefits. So you should be going ECS not just because of performance, but because of the flexibility, the scalability of your technical design in relation to game development, of course. Yeah. Yeah. And yeah, if you're like doing some stuff in Apparatus, don't be afraid of showing it. Some of our audience is actually doing it, and it's quite gaining more attention. It's quite I mean, it sure helps to spread the word. We are mainly organic traffic based, and we are quite successful here. But don't be afraid to show your experiments to the outer people. Spread it on the word, the hashtag of deprecating OOP, for example, and we'll be getting more and more people here, because I'm pretty sure the thing is like really useful. I'm sure you too, those who use it every day. And yeah, so maybe we'll be coming with some community-based trailer sometime, just a compilation of what people have done. But we're only like having Ethan with his zombie simulator, which is quite fun, right? It's getting it's getting some people here already. So yeah, maybe some more questions. This is our first stream. Yeah, it's not like a really well directed or well set. We'll be learning and maybe produce more engaging stuff. from now on. I think we will go into like make this maybe a 2-week based perhaps, and make some scenarios for the future streams, like for example implementing some basic like game mechanic, and it will be more engaging. But for now it's like an introductory one. Yeah, don't be afraid to ask. I'm here for your help, like really most of the time. So ask questions and help others. That's pretty much it. If you get in trouble with Apparatus, I'm also quite motivated to handle this stuff for you. So don't be like hesitant to set some bugs on me. But Apparatus is quite stable, I must say. For now, it's like really very. We have like very rare cases when we have to fix stuff, so it's pretty production ready, I must say. Yeah, thanks. I think the community is really quite uh, pleasant or constructive, I must say. That's because most of the people are actually professionals coming from some real game development background. You won't be seeing like really inexperienced people here when we're dealing with ECS, because ECS is quite new, and well, you have to know some things before going ECS. Well, I've tried outputting ECS transforms to or vectors to Niagara. It's doing fine, but it's quite well. This is a supported workflow to sync an array with Niagara, but I personally think that the instant static mesh is quite faster in terms of workflow, not in terms of performance. But in terms of performance, it's pretty much the same, I must say. So you're basically just losing all the GPU stuff in Niagara because you have to sync every frame and use it basically like in an instant static mesh. Really, no real performance benefit of using Niagara. Yeah, so Unreal Engine is coming up with its mesh solution. That may look like, again, like a competitor to our solution, but it's not. It's really good that they're implementing more and more ECS stuff into the engine, even as plugins, even as first-party plugins. But Apparatus is like really far gone, far in terms of functionality, in terms of expertise behind it, in terms of like versatility, general purposeness, so to say. So we are not really afraid of mess, and I think that there is a lot of things that has to be done to this mess framework before it comes near to Apparatus. Really, it seems pretentious, but you should really just compare as long as you have the access for the GitHub Unreal one, you can just compare some like basic stuff with what is currently in Apparatus, and it's like night and day, really. Apparatus as of today has already like passed the limit of being just a plugin long ago, actually, and now it's not even a framework, so to say. It's like an engine, really. It's like an engine inside the engine. So if you're going Apparatus, you're pretty much using Unreal Engine like an editor, Unreal Engine editor, right, and the renderer. So the Apparatus is like your general purpose solution, low level one. It's like a language because it has its own subset of C++ applied, so to say, and utilized. It's like a tool, of course, and it's like its own piece of software already. Sure, it exists in terms of Unreal Engine's plugin, but it's more than this already. No, it's not that it's like an ad or something, but it's also a precaution, because if you're going Apparatus, you have to like switch your mind over Unreal Engine's object-oriented design, this one, and go all the way ECS, really. If you really want to get most of Apparatus, you really have to go ECS, like maximum effort. And I'm most certainly sure that I most certainly think that you won't regret that. You'll have less time dealing with some object-oriented quirks and object-oriented flaws, even when you go data-driven all the way. And you shouldn't really be afraid about the possible career hits, like if you're going with some new technology and you won't be able to apply it professionally. Now, more and more people are actually going with their own ECS solutions, their private ones, and you should be fine if you go with ECS. Most certainly you won't lose your time. Like, you can actually learn some data-oriented design patterns and even apply them in OOP environments. Yeah, so it's almost like 2 o'clock here. I think we should be wrapping up. It was really nice to have you on the stream. We had like 10 people, and it's fine. I think it's fine. More will see this on the record. Yeah, and just prepare the questions for the next stream, I think. And we'll be going with a scenario-based one, so it will be more engaging, more entertaining to watch. So let's say we just like getting acquainted with each other here. Yeah, and if you need some more additional like features, don't be afraid to ask for them. Maybe they will be part of the Apparatus, the official toolkit. Maybe there will be even the core functionality. I'm not sure about that one, but maybe. Yeah, it was nice to have you with us. Spread the word. Make sure that people actually know that there is a native ECS solution for Unreal Engine. Of course, you have to like practice some stuff before you're like making advice. But yeah, I think that you won't like regret going ECS and turning people ECS. Thanks. Thanks, guys. I'm really like dig your support, and it means a lot for my motivation. Basically, I was like, no, there was time I was like maybe making it open source or something, but I think the current state of things is like the best one. So people like get to know us as a software developer. They get to know us as tools creator. They know they can like believe or trust our expertise, and bring the money to us. And it's quite logical that in turn we're delivering the software. It's the best real life like experience for the software, I think. And yeah, well, everyone is doing good for the industry and for the ECS in particular. Even these entities, or how do you say it, flags, frameworks, they're all fine. Yeah, we shouldn't really like bog them down or make them look worse than they actually are. They're fine projects, right? But we're like having our own thing here, and we are thinking ECS large. So our whole vision is to make like the whole system of ECS driven sub projects. Maybe we have like additional plans for the networking, not the core one maybe, but we still have to make the lockstep implementation a standard. It will be quite healthy for the industry also. So there are a bunch of things that has to be done. Yeah, in our own style and standards. Yeah, so keep on apparating, and see you next time, I guess. Thanks for coming. Bye.